first question involves area of trapeziums. From your formula sheet, you should see that the area of a trapezium is a half multiplied by a plus b multiplied by the height. A plus b are the lengths of the two parallel sides of the trapezium. I'm going to work out the area of the larger trapezium first. I'm going to call that large trapezium. This is a half multiplied by the two parallel sides added together, multiplied by the height, which is 6. If we work that out, we end up with an area of 54. The smaller trapezium, we do the same thing. This is a half, the two parallel sides, multiplied by the height, and this gives us an area of 18. It wants to work out the area of the shaded region. The shaded region is the large trapezium take away the small trapezium, which is 54, take away 18, which gives us an area of 36 centimetres squared. Question 2 is a substitution question. It wants us to work out the value of p when n is equal to minus 2. We can see that p is n cubed, take away 5. We can type this in our calculator. Minus 2 cubed is minus 8, take away 5. This gives us an answer of minus 13. Question 3 is an indices rules question. When we multiply indices, we add the powers, so we end up with 3 to the power of 5. And when we divide with indices, we subtract the powers, so we are left with 3 to the power of 2. It wants the value of this. The value of 3 squared is 9. Question 4 is a ratio question. Keith and Graham are sharing some money in the ratio 4 to 3, meaning that Keith gets 4 parts, Graham gets 3 parts. In total, that's 7 parts that they're sharing this money into. So we do 198.45 divided by 7, and this means that each part is worth £28.35. As Keith gets 4 parts, we do £28.35 multiplied by 4, and this gives us £113.40. So in total, Keith gets £113.40. Question 5 is a speed, distance, time question, but this is split into 2 parts: a journey from Fulbeck to Gamby and a journey from Gamby to Horton. The first important part of the question is here. It says that Raksha leaves Fulbeck at 10 o'clock and drives at an average speed of 40 miles an hour. Here we know that the distance that she's travelling is 10 miles. We know that the speed is 40 miles an hour, and from there we can work out the time. We know that speed is distance divided by time, so we know that the time is our distance divided by our speed, which is a quarter of an hour. This is the same as saying 15 minutes. So she leaves Fulbeck at 10 o'clock and will arrive in Gamby at 10:15. It says that she wants to get to Horton at 10:35. This means that she has 20 minutes to travel the 18 miles from Gamby to Horton. We want to work out the average speed that Raksha must drive at from Gamby to Horton. We know here that the distance is 18 miles. We know that the time is 20 minutes. And we want to work out the speed. Time being 20 minutes won't help us in miles per hour, so we can say that this is 20 out of 60 of an hour, which simplifies down to a third of an hour. Speed is our distance divided by our time. So in our calculator, we can do 18 divided by a third, and this will give us the average speed for her journey, which is 54 miles per hour. Question 6 is an expand and simplify question. I like to do this using the grid method, but you might have another method that you've been taught. 2x times x is 2x squared, 1 lot of x is x, 2x times 3 is 6x, and 1 times 3 is 3. Putting those together, we get 2x squared plus x plus 6x plus 3, and we can collect together our like terms, leaving us with 2x squared plus 7x plus 3. Factorising fully, there is a common factor of 4 between these, but we should spot this as difference of two squares. 4x squared is a squared number, it's 2x times 2x, and 64 is a square number of 8 times 8. We can use this to factorise, and we get 2x plus 8 and 2x minus 8. We could factorise this as 4 lots of x squared minus 16, which can factorise to 4, x plus 4 and x minus 4. In the mark scheme that I've used, both of these answers would be acceptable. Question 7 is a similar shapes question. To start with, I'm going to label the size because I find that a bit easier to see. E to C is 8.1 and D to C is 5.4, and I've also been given that D to B is 2.6. I can see that E to C and D to C are the same line, so if I do 8.1 divided by 5.4, that means my scale factor from my smaller triangle to my larger triangle is 1.5. The length AE is similar to DB, so it will be 2.6 multiplied by 1.5, which gives us an answer of 3.9. It then tells us that the length from A to C is 6.15, and it wants to work out the length from A to B. We don't know how to work out A to B, but if I do 6.15 divided by 1.5, this will tell me the length from B to C. The length from B to C is 4.1, and then I can subtract 6.15, subtract 4.1, will give me my length from A to B, which is 2.05. Question 8 is a real life graph question. The first part wants to find the gradient of the graph. We need to choose 2 points that are easy to read from. I'm going to choose the points where the line crosses the axes. So we've got the coordinate down here, 140, 0, and 0, 190. Our gradient is our difference in y divided by our difference in x. We can see here our difference in y goes from 0 to 190, and x goes from 0 to 140, and this gives me 1.5. Now our gradient isn't 1.5, as it's going down, it's sloping downwards, our gradient is negative 1.5. Part B says explain what this gradient represents. It wants to know what this gradient represents, not what gradient in general represents. This gradient is talking about the depth in the water with respect to time. So we say something along the lines of the rate of change of the water depth, or how water depth changes over time. You must mention the water depth, you must mention some sort of change. The next question wants us to draw a frequency polygon. For a frequency polygon, we plot the midpoint against the frequency. Our midpoints are 5, 15, 25 and 35. So I'm going to plot our midpoint of 5 against 14, 15 against 18, and 25 against 26, and the last one of 35 against 12. We then join these up with a straight line. Make sure you use a ruler, unlike me. Join these up with a straight line, and there is our frequency polygon. Question 10 is a tricky change of subject to the formula question. We want t to be the subject of the formula. The first thing I'm going to do is to multiply both sides by the denominator of 4 plus t. This gives me p times 4 plus t is equal to 3 minus 2t. I'm then going to expand the bracket out, so 4p plus pt, doesn't matter which way around those letters are, is equal to 3 minus 2t. I then need to get all of the t's on one side of the equation so I can factor them out. So I'm going to take 4p away from both sides. I'm also going to add 2t to both sides. It doesn't matter which side you put the t's on, I just like to keep them positive. If you put them on the other side, you'll get an equivalent answer. So we're left then with pt plus 2t is equal to 3 minus 4p. I'm then going to factor the t out to leave me with 1t on the outside. I'm then going to divide everything by p plus 2 to give us t is equal to 3 minus 4p divided by p plus 2. The next question involves the product rule for counting. It has a combination lock which has 5 different numbers, 1 through to 5. It wants to work out how many different 3-digit numbers can be set for the combination lock. The first number, there are 5 different options, and for each of those there are 5 different options, and for each of those there are 5 different options, so it's 125 altogether. They would also accept 124 if you discounted the 553. Both of those answers were accepted. For part B, it says how many of the 3-digit numbers have 3 different digits. To have 3 different digits, the first one we had 5 possible options. That then excludes one option for the next number, and that then excludes the first number and the second number for the third option. So 5 times 4 times 3 gave us 60 different combinations. Question 12 is a bounds question. It says that the volume of a cup is 200 millilitres, and this is correct to the nearest 0.5. The lower bound for the volume of the cup is 199.5 millilitres. My cup could be between 199.5 and 200.5. It says the machine puts tea and milk into the cup. 175 millilitres correct to the nearest milliliter. So this could be 175.5 down to 174.5, and the same with the milk, 23.5 up to 24.5. Is it possible that the total volume of tea and milk put in the cup is greater than the volume of the cup? For this, we need the biggest amount of tea and milk, and we want the smallest volume of the cup to work out the most extreme answer. So the biggest that the tea and milk could be is 175.5 plus 24.5. So the biggest that this could be is 200 millilitres. We know already the smallest amount that the cup could be is 199.5, so yes, it is possible to have more tea and milk in the cup than the volume. The next question is a histograms question. As soon as we see the word histogram, we want to write down our frequency density. Our frequency density is worked out by taking our frequency and dividing it by the class width, which is the distance between the lower and upper of the class intervals. So for the first one, it's 120 divided by 100, which gives us 1.2. 140 divided by 50, which gives us 2.8. And for the rest of them, we get 1.6, 0.4, and 0.2. We haven't got a scale on our frequency density on the graph, however, we do know that between 150 and 300, the height is 1.6. So I can write this here as 1.6, and you should be able to see that follows as 1.5, 1, and 0.5, and we can fill in 2, 2.5, and 3. We can then draw the rest of our histogram. Again, please use a ruler for these. The first one we have between 0 and 100 goes up to 1.2. So for 100 we go up to 1.2 and across. Between 100 and 150 it goes up to 2.8. (150 to 300 is done for us at 1.6. 300 to 500 goes up to 0.4. And 500 to 600 goes up to 0.2. Part B wants us to work out an estimate for the number of people who took more than 200 minutes to reach their holiday destination. More than 200 minutes is the area of everything from 200 onwards. We already know that the frequency for 300 to 500 is 80. We also know the frequency from 500 to 600 is 20. We just want to work out the frequency from 200 to 300. We can do this by working out the area of the bar, or we can see that from 200 to 300 is going to be 2/3 of that area of 240, and 2/3 of 240 is 160. So putting those together, 160, 80 and 20 gives us 260 people. For the first part of question 14, it wants to work out the value of 2a plus 3b. 2a is double the vector a, which is 2, 8, and 3b is triple the vector b, which is 9, 6. And when we add those together, we get 11, 14. Part B, we've got the vector c drawn, and it wants us to draw the vector 3c. This needs to go in the same direction, but be 3 times longer. This one goes across 3 and up 2, so we're going to need hours to go across 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 6, 1, 2, 3, 4, 5, 6. So we're going to connect these up and make sure that our arrow is going the same way. Question 15, we're forming and solving an equation. It says that the length from A to D is x. It says BC is the same length as AD. That side is also x. AB is twice the length of A to D, so that's 2x. And DC is 4 centimetres longer than AB, so it's 2x plus 4. It gives us the perimeter of the trapezium. The perimeter is where I add all of the sides together. And it tells us the perimeter is 38. We can set that equal to 38. I'm going to collect the like terms, so we end up with 6x plus 4 equals 38. Subtract 4 from both sides, 6x is equal to 34, and then divide both sides by 6 to get that x is equal to 17 over 3. The question wants the length of AD. AD is x, so that just means 17 over 3, or we can leave this as 5 2/3. Question 16, it says the normal price for television is reduced by 28%. The sale price is now £345.60. We want to work out the normal price. This is a reverse percentage question. This means that £345.60 is not equal to the whole amount. This is equal to 72%. To work out what 100% is, I can first divide by 72 to find that 1% is equal to 4.8, and then multiply by 100 so that we know the whole amount is equal to £480. For part B, Paul bought a car. The value of the car was £15,000. In the first year it depreciated and it went down by 23%. I can work this out as 15,000 multiplied by 0.77. This tells us the value of Paul's car after the first year. 15,000 times 0.77 gives Paul's car a value of £11,550. After the first year, it went down by 18% each year, and it wants the value at the end of 3 years. So that £11,550 would go down by 18% 2 more times. So we multiply this by 0.82 twice, which gives the car at the end of 3 years a value of £7,766.22. It says to work out if Paul's car lost more than half its value by the end of the 3 years. Well, half of its value would be 7,500, so no, it's not lost more than half of its value. Question 17 is an iteration question. At the start of 2016 there were 30 grams of metal, and what will the quantity of metal be at the start of 2019? So P 2016 was 30, P 2017 will be 0.87 times the previous year, and then we do this twice more, 0.87 multiplied by our answer, and then for 2019 we do it a third time, 0.87 multiplied by our answer. Keep that value in your calculator rather than rounding it. We should have an answer of 19.755. This could be 20. They would also accept 19, as there's only 19 grams left. For question 18, we have a probability question. Katie is going to turn over at random 2 of the cards, and it wants to work out the probability they have different shapes on them. So different shapes, we could either have a circle and a square, we could have a triangle and a square, we could have a circle and a triangle, and we could also do this in the other order of square, circle, square, triangle, triangle, circle, and circle, square. This would take us a while to work out, so instead we can just do the opposite and do one take away the probability that they're the same card. So the probability that they're the same card is going to be a circle and a circle, a square and a square, or a triangle and a triangle. In total there are 2 circles out of 9 cards, and if I take one out there'd be 1 out of 8. Probability of 2 square cards, there's 4 at the moment out of 9, and if I took one there would be 3 left out of 8. And similarly for the triangles, there's 3 out of 9, if I took one out it would be 2 out of 8. I'm going to multiply those fractions together and then add the solutions, and we should get an answer of 20 out of 72. Now this isn't the answer we're looking for, remember we're taking this away from 1, so we get 52 out of 72 as our final answer. Question 19, y is directly proportional to the square of x. I can write this as y is proportional to the square of x. This can also be written as y is equal to kx squared. When x is equal to 3, y is equal to 36, and I can solve this and say that k is 36 divided by 3 squared, meaning that k is 4. That means I can write this equation out now properly as y is equal to 4x squared. It says to find the value of y when x is equal to 5. I will substitute 5 in. Y is equal to 4 lots of 5 squared, which is 4 lots of 25, meaning that y is equal to 100. For our circle theorems question, we want to find the angle C to A to O, which is marked here. We can start with the circle theorem that the radius meets a tangent at 90 degrees, and we can say that this angle here is 90, take away 56, which is 34 degrees. This also means the angle at the top is 34 degrees because I have an isosceles triangle made up from the 2 radii. Using the alternate segment theorem, we can see that the angle from C to B to A is the same as this angle down here. So the top angle is the same as the angle down here. This makes this 69 degrees, and using the same circle theorem as before, we know that this angle is 90, take away 69, which gives us an answer of 21 degrees. There are multiple ways to do this question. I thought that was the most straightforward, but all should give you the answer of 21 degrees. For question 21, we have a 3D trig question, which wants us to work out the angle between the line BE and the plane ABCD. This is quite hard to see on a printout version, but it's between the line and the flat plane at the bottom of the shape. We can first work out the length from B to D. We can use Pythagoras to do this, as we know that A to B is a length of 24, and we know that B to D is a length of 8. So for D to B, we use Pythagoras, and it will be the square root of 24 squared plus 8 squared, which gives us an answer of the square root of 640. I'm going to leave that as it is at the moment and have that dB is equal to root 640. Your calculator may show this in a simpler form, 8 root 10, or as a decimal, but I'm going to leave it like that at the moment. We can then set up another triangle from E to D to B. So we set that up as E to D to B. We know the length from D to B is the square root of 640, and we also know the length from E to D is 10, as that's been given to us. We want to find the angle from between EB and the plane, which is this angle I've marked X. And we can use SOHCAHTOA to do this. I've got my opposite, I've got my adjacent, so I'm going to do tan of my angle is equal to my opposite over my adjacent, and if I use inverse of tan, that will give me my angle, which is 21.6. Our penultimate question is quadratic simultaneous equations. We cannot cancel anything out, we cannot add or subtract the two equations to cancel things because we have squared terms in the first equation, whereas we don't in the second. Instead, I can rearrange this second equation to say x is equal to 2y minus 3, and I can substitute that into my first equation. So my first equation is x squared plus y squared equals 18. I just substituted our value of x from the second equation into the first equation. I can then expand these brackets. Remember, this is a set of double brackets. We can expand however you would normally expand two brackets. I use the grid method to get 4y squared minus 6y, minus 6y and 9. This means that that expanded is 4y squared minus 12y plus 9, add the y squared, equal to 18. To solve a quadratic, we need everything on one side of the equation. We need our equation equal to 0, and I'm going to collect my like terms as well. So 5y squared minus 12y minus 9 is equal to 0. There are different ways we can solve the quadratic. You could use the quadratic formula, but we can factorise this. We know we need 5y and y, and we want it to be minus 9, which would be minus 3 and 3. Checking this works, we'd get 3y from the 3 and the y, and minus 15y from the minus 3 and the 5y. This means that y is negative 3 over 5, and that y is positive 3. So we have two of our y coordinates. We have 3 and minus 3/5. I'm now going to work out my x coordinates, and I'm going to use this second equation to do it. I can substitute our values of y into this equation to work out x. We know that x is equal to 2 lots of whatever our y value is, take away 3, and I also have for the other y coordinate 2 lots of 3, take away 3. These gives us y values of minus 0.6 and 3, and that is your set of solutions there. Our final question wants us to write it as a fraction in its simplest form. As soon as I see simplest or simplify in an algebraic fraction, I want to make sure I can factorise something. The first fraction we can't factorise anything, but the second fraction you should spot the denominator is a difference of two squares, x plus 1 and x minus 1. This will make writing it as a single fraction much easier. So to write it as a single fraction, I want a shared denominator of x minus 1 and x plus 1. second fraction is already there. The first fraction I need to multiply by x plus 1. I'm then going to expand the bracket on the top out but leave the bottom as it is. So we get 2x squared plus 2x minus 7x. And remember, I'm taking away a negative 3, so that will become plus 3. And I can write all of that over our single denominator of x minus 1 and x plus 1. We can see we can simplify the top, so we get 2x squared minus 5x plus 3 over x minus 1, x plus 1. It wants us to write it in its simplest form, so we need to check again if we can factorise the top. We can factorise the top of the fraction, we can factorise the numerator, and we can factorise this to be 2x minus 3 and x minus 1. And we can see we can cancel the x minus 1's out to be left with an answer of 2x minus 3 over x plus 1. Thank you for watching. I hope you found these papers helpful. Please do subscribe if you can, it does help, and there'll be more walkthroughs and some exam tips coming soon. Thank you for watching.